Hello, good people. Today we're going to look at an example of a Bernoulli equation. So we have xy prime minus 3x plus 2y equals negative 9x e to the negative x times y to the 4/3 power. And this is a Bernoulli equation because I have it ends in that power of y, and that power does not equal 1 or 0. So I'm good to go. First thing I want to do is rewrite it so that it's in the particular form, meaning I want to just a plain y prime minus this is my p of x, and that's my q of x, and this is y to the n. So n equals obviously 4/3. Now there's two things I have to do. I have to make a certain u substitution. U equals y to the 1 minus n. I also have to divide both sides of this equation by y to the 4/3. Doesn't matter which one I do first. I may as well just do this one first. So I divided everything by y to the 4/3. So now I get y to the negative 4/3 times y prime minus 3x plus 2 over x times y to the negative 1/3 equals negative 9 e to the negative x. And that doesn't look much better than I had before, but it's going to help when we do our substitution. Anyway, what is this substitution I'm talking about? Well, here it is. It's u equals y to the 1 minus n, which is y to the 1 minus 4/3, and that equals y to the negative 1/3. Now, once I know that u equals y to the negative 1/3, I can very easily get u prime. U prime is negative 1/3 y to the negative 4/3 times y prime, which now I'm solving for this little piece of it right here. So this little piece right here, just bringing the 3 over to the other side. So negative 3 u prime equals this sucker right here. Now, why did I do that? Because because now it's exactly that. So I could do another substitution now, or I could well, you see what I'm talking about. I could take the u now. I could take this u. I could rewrite this equation in terms of u's. So this little sucker here is equal to negative 3 u prime, which we just showed over here, and this is just u, so it's 3x plus 2 over x times u, and that equals negative 9 e to the negative x. So now I have this. So what did I do? What did I really accomplish here? Oh, and of course I want to divide by negative 3 because I like to have the u prime by itself. That's the standard form for these kind of guys. So I get u prime equals x plus 2 over x times u, which is equal to 3 times e to the negative x. And what did I really accomplish here? I took an equation that was a whole big messy form. I didn't know what to do, and I manipulated it with substitutions and all kinds of clever algebra, and eventually I got down to a typical linear differential equation. And we learned two methods of how to solve a linear differential equation. We learned integrating factor, and we learned variation of parameters. So for this example, I'm going to actually do it both ways, and you'll see we're going to get the same answer either way. So I'm going to do it first with variation of parameters. So what I do for variation of parameters is first I take the differential equation and I take out the I start with the differential equation. This is now sort of my new original differential equation in a way, and I set that equal to 3. I turn this into a 0, I mean looking at the corresponding homogeneous version of this. And once I have this is all equal to 0, this is going to be a separable differential equation. So I get, and I'm using u1 is the specific solution I'm looking for. I just need one of them. So du1 dx is equal to negative x plus 2 over x times u1. I integrate both sides, and that gives me ln u1 equals negative x minus 2 ln x. You could figure that out. It's a very easy integral to do. And I exponentiate both sides, so I get u1 is equal to e to the negative x times e to the negative 2 ln x. There's a bunch of algebra steps which I'm